Greetings everyone, my name is James Ramabu. I will be presenting under this topic, Teaching and Learning CS1 with an assist of manipulatives. Some students succeed in programming, others don't, and the solution we are bringing forward is basically for those who don't, the struggling students. Different pedagogical methods are tested. Some lecturers try different methods in order to emphasize these challenging concepts or focus on struggling students. The use of manipulatives, some of these educators make use of manipulatives. At the end, they try to foster understanding of some of the CS1 concepts. Introduction of teaching and learning programming with manipulatives. So in this case, we're developing that TLPM with the purpose of having a framework, and this framework will be used by lecturers to choose the manipulatives or to develop the manipulatives. Okay, the objectives basically this paper will talk about existing manipulatives, and then we also talk about the action research results. We have some manipulatives that we use to teach to emphasize the concept of assignment. The methodology we are following is action research, whereby we apply the proposed pedagogy to the real students in the university. The students, all the struggling students doing introductory programming will be divided into two. That's the control group and the experimental group. The control group will not be taught with manipulatives. Experimental group will be taught with manipulatives. So we'll be making use of pre-teaching exercises and post-teaching exercises to compare the two groups. Existing manipulatives, in the literature I found a whole lot of them that are used by teachers in the K-12 stream, lecturers in the university, some educators as well. They make use of these manipulatives: Anglo blocks, robotics, flashcards, CS Unplugged, Russian dolls. And then again, in the special interest group on computer science education, we ask a question in the mailing list whether they are using these manipulatives or not. And we found that some of them are actually using the manipulatives to teach some of the CS1 concepts. Again, the Russian doll, I have a picture of a Russian doll here as one of the example of manipulatives that are being used. So in this case, what happens is that some educators make use of these Russian dolls to emphasize the concept of recursive functions. The process here is that each doll fit inside another doll, and then at the end we have many dolls inside one bigger doll. So the process of invoking or removing one smaller doll out of the whole thing, it represents how recursive functions work. So some of the lecturers make use of that to teach recursion. So this is just one of them. Okay, so here we identify some manipulatives, and then after identifying some manipulatives, we have some scenario, we have the pre-teaching exercises and the post-teaching exercises. And this is a setup of a pre-teaching exercise. Given variable x is 7, p is 12, write a C++ statement that copies the value of p into variable x. What will be the value of x and p? So 5 out of 30 people answered that the value of x will be 7. And in this case, when you look at that, the value of x cannot be 7. So meaning that there is a misconception on how this assignment works. And then again, a total of 6 out of 30 answered that the value of x is equal to 19. Where did they get 19? The misconception again is there. Is 7 plus 12 is 19. But when you look at the question there is nowhere where it says the value of x and p should be added together. But I think x is equal to p. The misconception will be that p, the value of p is being added into the value of x. And then at the end, the student don't really understand how assignment works. So out of these students, you can see that we have that number that really do not understand assignment. So we went and identified some manipulatives. We had 2 cups x. The first cup represents a variable x, and the second cup represents the variable p. And then inside these cups, you had papers written 4 and 3. Those numbers inside the cups represent the values inside the variables. So when you say x is equal to p, what will happen is that we got another paper which has nothing on it, and then copied the value of the value there, which is 3, inside the cup p. So we told the students that now we are looking at that value inside cup p and copy it on this new paper. And then after that, we went to the cup x, and before we inserted the new paper there, which represent the new value, we removed the value 4 and throw it away, throw it on the floor, meaning that now it's replaced by the new value, which is 3. And again, when you demonstrate with this cup, you cannot actually remove that paper inside P and insert it inside the cup X, because when you are copying here, we are not removing the value out of P. So that kind of misconception has to be cleared when you are demonstrating the manipulatives. So at the end, the students were able to understand that when the value is copied from right to left, it's actually copied, it's not removed from cup B, and at the end is not added, it's replaced in the cup X. Hence, whatever value that is in the cup is removed, and the copy is the one that will be stored inside cup X. Okay, we have another experiment there. If X is 8, Y is 10, T is 15, what is the value of X and Y after the execution of the given code? A total of 12 out of 30 indicated in their answers that the value of Y is 15. The misconception here is the incorrect value of Y, because as you check there, the first line will be T is equal to X, meaning that the value of T changes right at the beginning. So later, when Y is equal to T happens, the value of T already changed. So again, we made use of caps. So that process of T is equal to X, X is equal to Y, Y is equal to T, we demonstrated it with these caps. And then where we had an empty paper, and then copied where necessary until the whole demonstration happens, just how we demonstrated here. And then now the student understood that, okay, the value of T changed, and then later the value of T, the value of Y will be updated with the new value of T. Okay, so the major output result, the average grade marks for the post-teaching exercises on the experimental group was 2.29, which is higher than the control group grades. And then again, at the end, we had some post-teaching exercises where we compared the two groups. The others were taught with these manipulatives, where the concept of assignment was emphasized with manipulatives. And the other group they were taught traditionally without the use of manipulatives. So at the end, based on these um, post-teaching algorithms, we noted that there were improvements when we compared their results. There were improvements on the experimental group than control group. And then again, 2 students from the experimental group achieved more than 80% on the pre-teaching exercise and post-teaching exercise. So when we made an invitation that all the struggling students must come so that we can help them with the use of manipulatives in the introductory programming concepts, there were students who were not really struggling, but they came. But now, how did we trace this? When you look at their pre-teaching exercises, they got it right more than 80%, and the post-teaching exercises, they got it right, meaning that if they got the pre-teaching exercise correct, they don't really need intervention. They don't necessarily need intervention. They have some basic understanding. Again, for the experimental group, the performance was better than the control group on both post-teaching exercises. So this is actually the overall result, that the experimental group, there is an indication that the use of manipulatives enhance comprehension in the CS1, some of the CS1 concepts. Conclusion, a lesson learned from the experiments is that the students are more enthusiastic when teaching and learning is accompanied by assist of physical objects like manipulative. So as we were teaching, we noted that students were eager to learn, were more interested, because when we introduced these manipulatives, they were looking forward, they were even discussing. And then we have also learned that the manipulatives can be developed for both struggling students with simple CS1 concepts or more challenging CS1 concepts. So as this is an ongoing research, we will still identify some concepts that we can develop or identify some manipulatives and use them to emphasize some of the concepts. So we can target students who are struggling with basic concepts, or we can target the challenging concepts and develop appropriate manipulatives. We will use the lessons learned and relevant theories to develop the TLPM framework. So the main thing here is to develop a framework so that when anyone or lecturers who want to identify some manipulative, they may benchmark their manipulatives against the framework, and just to make sure that the chosen manipulative is actually helping students to learn, is not doing harm, is actually promoting learning. Because currently we haven't found an appropriate framework that really help the choosing of the relevant manipulative. As a future work, we'll identify the manipulative for struggling students and test through action research methodology. So this is an ongoing research. We'll continue identify these manipulatives and then testing them as we develop the framework. Thank you very much. Thank you.